Welcome to a presentation on detecting data leakage in SQL databases. My name is Kyle Pazendak, and I am a security engineer and software developer in the Apple space that specializes in enterprise software management. Today, I am talking about a simple method of detecting data leakage by using regular expressions. This is a simple sanity check to verify on edge transfers that PII, GDPR, or other protected information that you can properly describe aren't leaking into unapproved areas. Data leakage is the unauthorized transmission of data from within an organization to external destinations. It can also occur when data transmissions stay within an organization but move between defined boundaries, such as being stored in different countries, regions, or even continents. The act of moving it between teams within a company can also be the cause of data leakage. Data leakage is one of the biggest lawsuit areas for consumer-facing software services, where information that has a protected classification. GDPR is a very common compliance standard that software companies that work with citizens in the European Union follow. It codifies several important data privacy rights, such as allowing the person that the data describes to be informed of what is collected, assessing the validity of it, and recertification and erasure of data. And of course, object or restrict to the methods that the data can be used by the company. Along with these, companies are required to maintain data privacy policies, define zones that the data exists in, and how it is used, including the internal repurposing of data or the sharing with external organizations. Some of the largest tech fines of the last 5 years have come from GDPR failures and the leakage of data beyond what was expressed to the users of the software. This makes it important to define your use cases, express those throughout the organization, and then benchmark yourself to ensure compliance. Across the pond in the United States, HIPAA is a common framework as well, defining much of the same information as GDPR, but regards to personal identifiable data and private health information. Data may be facts about a person, such as their social security number, or even temporary information, such as a credit card number. If you fall into HIPAA, you will likely have a data management policy that describes the entire lifetime of the data, and the legal retention periods may extend years for platforms such as email, database backups, or any specific area that protected data might end up in. Outside of the legal compliance standards, there also exists data that you simply wouldn't want to become publicly available or cross organizational boundaries. This is often referred to as company-sensitive information. You might have shared secrets, encryption keys, or any other information that would be harmful to the company. Methods on detecting and handling these should also be defined. This brings me to the demonstration of this video, specifically an engine that allows you to examine a database holistically using regular expressions. This method is common when doing static analysis of databases for potential fields that may contain protected data types. This comes in the form of extensible fields like notes or comments or any field that you may not be sure what is contained within it. It is also a common method for verifying data transformations, redactions, or obfuscations when transferring between regions. This could be for examining to ensure that fields are in fact dropped when they should be. Okay, let's go ahead and take a look at this. First, we have a very simple application here. All it does is if you run it, it says test regular expression. It goes ahead and loads a database connection and then prints the tuples if there's any tuples of a database. Let's go ahead and look at the actual application from the GitHub. So here's the application itself. Pretty straightforward and self-explanatory. You have a host name, port, username, password, database. These create a connection string, in this case MySQL, but you could extend this out to just about any other database. Like Oracle or Postgres. And then you have the ability to set a regular expression and then search all of the tables for that regular expression. And it goes ahead and what it does is it'll take the output, the check tuple here, it'll take the output, cast it as a string, check it against the regular expression right here with re.search, and then that's it. So let's go ahead and take a look at what happens when we run this. Right now, it shows no matches. So let's go ahead, and I have the database up here already. Select star from person. Right now, we're just doing a simple one-table database. You can see we have a bunch of different people here. We have birthdays, addresses, and we also have notes. In this case, when we were looking at the test, what we were looking for is, does a serial of what appears to be a social security number exist? So you have 3 numbers, a hyphen, 2 numbers, a hyphen, and then 4 numbers. So let's go ahead and insert a value into this. So right here, we're going to insert a person named John Doe into the database, and then we'll see what happens. Row 1, good to go, select star. So then now we notice that on the notes section here, we should get a hit on this. So let's go ahead and run this application again. Now, if we run it again, we'll see that it is a table and then the field itself that contains this information. Now, we could switch up the regular expression to say birthdays, if in this case we wanted to make sure that birthdays were dropped or addresses were dropped or any other information were supposed to be dropped from this database. In this presentation, I talked about the importance of verifying that PII and GDPR data aren't present in a database. I showed a method of how to do this by using regular expressions and grabbing unique values from each column to test for patterns. Use this ability to return the tuple of the table and field combination if the regular expression succeeds. This method also shields security teams from knowing exactly the information that caused the issue and limiting the data exposure to allowed people. I hope you enjoyed, and thank you for watching.